Hello guys, in this video I'll show you a project that I've been working on for the last few months. It's my personal project. The original idea was to build a hydroponic greenhouse. Given that I live in Poland and there is a war behind our eastern border in Ukraine, the other important factor that I've started to consider is building a self-sufficient greenhouse and independent power supply to my home, because the future is a little bit blurry. We don't know how would the war impact us in terms of the energy supplies in the near future. So given all those things, let me just show you how the greenhouse operates and how I've achieved, or at least I'm trying to achieve, energy independence in order to build a self-sustaining food supply through the greenhouse. Okay, so let's get in. Oh, by the way, the dimensions are 4 meters by 10 meters. And as you can see, we've got a large fan, so apologies for the noise. So this is how the greenhouse looks like. It all started 3 months ago. Exactly 3 months ago, all the plants that were seeded were like 3 centimeters high, and now they look really nice. So what we've got here is we've got 4 Dutch bucket hydroponic systems, so closed loop systems where the water circulates from the tank that's over here, feeds the plants and then drains back to the tank. Of course, you need to use fertilizer that you mix with the water. So we've got peppers on that side, and you can already see how nicely they started to grow. We also have kohlrabis, so 2 rows of buckets, and we've got tomatoes. These are the largest ones, but there are different species, and they also are growing really nice. And we've got 3 cucumbers at the very end. Apart from Dutch bucket systems, we've got NFT lines, which are continuously feeding water with fertilizer, with nutrients. And here we grow our leafy greens that we eat on a daily basis. So we've got different kinds of lettuces, different kinds of mints, coriander, basils, so quite a large variety, and they work really well. They really grow super fast. Okay, so this is how all those systems are being set up. If you're keen on understanding more about hydroponics, then there's plenty of material on the web. Just go to YouTube. The nice thing about it is you plant your seeds into these rock wool cubes. I'm not sure if you will be able to see due to the light, and then you just pop them in over here and they grow out. Okay, so it's very nice and clean. And then if you want to take out the plant, you just pull it out with the root system, and that's it. No soil. I'm not using any herbicides, pesticides, so it's clean food, and it grows very quickly. And one reason for that, through my short experience but noticeable experience, I could see the effect, is having a large fan on one side, having a shade cloth, 40% shading. You can see that the whole greenhouse is sealed. It's locked. I'm not opening any doors except these doors on the outer side. And today we've got 30 degrees heat outside, and you can see that the temperature inside the greenhouse is roughly between 20 to 23 degrees Celsius and 60% of humidity. And all that is achieved thanks to the fan as well as evaporative cooler. this is one of the greatest things inside the greenhouse, because what it does, or actually what it is, it's just a cardboard with tunnels in it through which the vent sucks the air from the outside of the greenhouse. So you can see this is an open space, the doors are opened and the air is being pulled from the outside, and there's a feed line that is feeding above that cooler water, and the water flows down. It's being collected through the gutter and flows down to the little tank, some tank with a pump that's pumping the water again. So it's a closed, well, it's not a closed circuit because the water is evaporating through the process, giving a very important thing, which is decrease of temperature, even by 10 degrees in high outside heat temperatures like 36 degrees. Inside I was able to maintain 27, 28 Celsius degrees with completely locked greenhouse. I did not open any doors or windows. All the air was flowing through the evaporative cooler. The other important thing is it maintains humidity. So the humidity is around 50-60 degrees percent, which does not dry out the plants. They don't go into that survival mode during the day when it's too hot. They can grow during the day as well, and that actually sped up the growth of all of those plants. I could see with my own eyes that it's working. But remember that if you install this, you need to have an external supply of water to that little tank. The supply is controlled by the valve, this red thingy, because the cooling is happening through the evaporation of water, and it can use up tens of liters of water per day. So there's an external tank situated behind the greenhouse. Right, so this is how the greenhouse looks like. So far it's working really well. So now let's move on to the next thing. How do you actually self-sustain the greenhouse? It needs power. It needs power for the vent, it needs power for the pumps that supply evaporative cooler, it needs power for the pumps that feed water into all those hydroponic systems. There are lights at night so you can work. So how do you achieve this? Well, the idea here was to not rely on the grid power for obvious reasons. It can become unstable due to geopolitical situation, and that's why I've decided to go on and use photovoltaic panels. I've got 9 of them, 410 watt panels, and I've also set up a hybrid inverter configuration. So the hybrid inverter is the one that does not rely on the grid power. If there is no grid power, it will still operate. It will use the power from the panels as well as the batteries. So I will have an energy bank. I don't have the batteries yet, but the energy bank will be able to store around 11 kilowatts of power. So that's just 1 day of usage. But that should be enough just to buffer the energy in case there is a bad weather outside. I can still rely on it. And that's a very clever thing, because it will, or you can actually configure it so that it can either charge from the panels or from the battery, or can recharge the battery as a priority, and in the very least priority use the power that comes from the grid. Okay, so you can still use the power from the grid. Actually, I'm using the hybrid mode right now, so this is the power coming from the grid if it's needed, but the priority is the power coming from through MPPT controller from the panels. And as you can see, we've got 535 watts taken from the panels and fed to the greenhouse. So basically the whole greenhouse is right now self-sustainable. Of course, we've got the weather today, so all the power is coming from the panels. Okay, so you can see the voltage from the panels, current to amps, and the power. Just as a proof, because you know it's working in a hybrid mode right now, but I've got two energy counters, one that's coming from the grid, so you can see 16 watts coming only from the grid, possibly to supply the inverter, because I haven't disconnected it. I can disconnect it, and then obviously it will just rely on the photovoltaic panels. And there we've got the counter that measures the energy taken out from the inverter. So 452 roughly matches what we get here as the power taken out from the photovoltaic panels and fed to the greenhouse. Okay, so this is how you can achieve the self-sustaining power supply, food production, hydroponic system with the use of hybrid inverters. And another nice cool thing is you can actually, rather than tinkering and configuring and monitoring it through the panel, which is situated in my garage, you can connect it to Raspberry Pi. That will then feed all the data and let you configure it remotely through a very clever system. And this is something that I'll show you in a sec when I get to my computer. As some of you might have already guessed by looking at my previous videos, the system that I'm using to control the automation of the greenhouse, when the water pumps are kicking in, when the fan is kicking in, what temperatures are being measured, the system that I'm using for all those purposes is Home Assistant. And Home Assistant, of course, works really nice for home automation, for IoT intelligent sensors, but it works really nice as well for the greenhouses. Okay, so you don't need to be skilled IT professional to set it up. You don't need to write even a single line of code if you don't have to. There's plenty of materials on the internet and YouTube, and it's an open source solution. So really nice system. So what I'll do is I'll show you how I've set up the greenhouse, what's the energy usage, and how the inverter that's feeding the power to the system is working at the moment. So over here we've got all our information organized in different tabs. We'll just look at those three aspects of the configuration. First, the greenhouse. There are different tabs that I've organized all the control and monitoring for the greenhouse. So this is the general tab where I can see whether the lamps, back doors, and fan is working, what's the temperature, what's the humidity, and whether all the units, microcontroller units, systems and sensors are operational and connected. We also have cameras, so if we wanted, we can take a preview and see what's happening inside the greenhouse. There's also an automation that takes snapshots every hour, 24 hours, and we just to see how the plants are growing. The cameras can tilt, move vertically and horizontally, change position. So that's a nice way to, that's a nice prelude to provide some AI image recognition automations, detecting problems with the plant growth, pests, or anything that's affecting their growth. Okay, so this is general tab. Here we've got the climate control tab, showing what are the temperatures, whether the evaporative cooler wall is working, whether the large fan is working, what's the power usage, when it's kicking in, at what time. Remember, every 2 minutes it's verifying whether the temperature drops below, I think, 23 degrees Celsius, and then it kicks in, and it stops when the temperature is below 24 or 5-ish Celsius degrees. And here you can see the operation. Maybe the blue line is the most objective temperature, because this sensor is closed in the box that heats up. and this one is next to the plants in the shade on an FT1 tray. So let's just have a look at this one. So you can see that the temperature is oscillating between 23 and 25 degrees. This is when the fan turns on and off, and then at night obviously the whole greenhouse shuts down, the temperature, ambient temperature drops down, and then there's a new day, so it starts the process again. The nice thing again is the humidity. If you take a look here, starting from the noon yesterday, which was a warm day, like 27 Celsius degrees, the humidity is pretty much sustained at the same level, allowing the plants to keep growing. Okay, so this is the humidity control. Here we've got a watering tap, so we've got 4 Dutch systems, 2 NFT systems, and here we can control how and when the watering takes place. Of course, there's an automation that kicks in the pumps for Dutch system. They don't need to work continuously, only 4 times a day for 1 hour each cycle of watering. Of course, we can enforce the watering by our own switches exposed. You can see we're measuring the amount of water flowing out of the tank, and then of course the amount of water that will be fed back into the tank as well. Okay, so let me just turn it off because we don't need it now. Next thing is, of course, we can control the doors and all the relays that let us open the windows. Actually, we're not using the windows anymore. The whole greenhouse is sealed, but that was the purpose of that tub. We're also using intelligent plugs. In some areas, I'm just using those plugs to monitor the power usage. For example, the Dutch plug voltage. So for Dutch 1 line, there's a pump that's being used, and that's what the power usage will be shown. We can monitor individual devices, and we can also turn them off through automations. Okay. What else? We've got weather station, so wind speed, rain. It's all captured in real time and monitored. And also we've got our monitoring of the Raspberry Pi and Home Assistant system. Okay, so this is the greenhouse. Let's move on to the energy usage. So basically, looking at yesterday, because we're measuring the power usage through all those intelligent plugs, I can pinpoint and understand which units, which devices inside the greenhouse, but not only, also at the home. By the way, this is TV at the moment. I can monitor the energy usage, the power usage. So this is how the outline looks like at the moment. For yesterday, the usage mostly for the greenhouse was almost 15 kilowatts, but you need to remove from that garden pump. This is a garden pump that feeds water to water my grass, the whole garden, and it generated almost half of that value. So pretty much in general, hot day, 27-28 degrees, fans working, evaporative wall working, 7 kilowatts usage of power by the greenhouse. 7 kilowatts is somewhere around 10 watt, possibly. Oh, sorry, less than 10 watt. 5-6 watt at the moment. So it's just £1 British pound or 1.2 USD dollars. So that's not much, but as I said before, we want to get energy independence. We want to have the food production through hydroponic system to be self-sustaining and independent of the grid. So that's why we go into off-grid setup. And you've seen the inverter. Here you can see all the parameters that are taken out from it and communicated through Raspberry Pi. So we've got photovoltaic efficiency, power in watts, current, voltage. If we install batteries, we will see what's the battery charging state, whether we're using the battery, and then of course whether we're using grid or not. More importantly, we can also set up the charge and power feed line priorities. So based on the weather forecast, Home Assistant can be used as a controller to manage how the inverter, from where the energy is being produced from the inverter. In future, maybe you can connect that inverter to the grid, and you can sell energy if, for example, the energy price goes up at a certain point in time, maybe at night. But that's just a very generic idea. I don't think I'll be going into that. I just want to reuse all the energy I produce. And this is just the summary tab I've just created to monitor the greenhouse power supply through the PV panels. As you can see this morning, this is where I've connected the whole greenhouse to the inverter, and all 530 watts are coming through the solar energy. So from that point in time, I'm not paying for that energy. I'm not using the grid to supply that energy to the greenhouse. Obviously, I would need to make more tests and understand what's the maximum energy that can be supplied through the inverter alone without using the grid or batteries, but so far it can sustain 0.5 kilowatts, which is not bad, but possibly it's just a small load. It can produce way more. That's why the batteries would be nice to have, so the inverter could at the same time charge batteries as well. Okay, so I think that these are the most important parts of what I wanted to show you. Maybe another last interesting thing is to have influx and Grafana for time series monitoring. So this provides you more convenient way to look at the performance of your system over a longer periods of time, where you can produce charts and monitor, observe trends. For now, I just set last 7 days, and obviously we've plugged in the inverter today, but we're monitoring the power generated or used by the greenhouse by the inverter. Right now it's only greenhouse connected to it. In future, other home appliances will be also will also use the energy supplied by the panels. We can use the Grafana, for example, to monitor greenhouse temperatures. So what's the temperature inside? As I said, the cooling works really nice. You can have a look at the humidity. Actually, this is the objective temperature and humidity. So as you can see, in the hottest days, the temperature did not go above 30 degrees, and still the humidity was maintained at high levels, meaning that the plants could grow. And there's plenty of other KPIs that I'm monitoring, and that they can be used to trigger alerts or automations. Okay, so I think that's all I wanted to show you today within the context of building a self-sustaining food production system. So far it's working really well. I hope you enjoyed this presentation, and of course, if you're interested or curious about certain parts of the solution, you can write in comments and I'll try to address them. Thank you very much. Bye.